So, what should you do for today's tutorial is 1 hour. So I'm going to repeat it, and because it's 1 hour, likely won't get through everything today, but that's fine. We'll talk about the rest of the walkthrough next week for anything we don't get to. Okay, so how are you going to attack Milestone 2? Milestone 2 is a bit more open-ended than Milestone 1. So the first thing you should do is download the Milestone 2 handout uh, and follow the walkthrough in section 4 of the handout. So that'll help you get going. Now, you're using graphics in Milestone 2. So you need to understand the graphics library that we're using, which is called EasyGL. And we've written a quick start guide for that. And you should go and read that quick start guide. It tells you how to use the library, particularly the first part of the quick start guide. The first part is like, this is the part you need to know how to use. And then the second half is kind of, here are more advanced things you could do if you wish, but you don't have to. They might be cool features that you might explore, but they're totally optional. But the first half is the basics of how to use this graphics library, and you will need to understand that. You're going to modify your main.cpp. So in Milestone 1, you didn't bother writing a main program. It was all about unit tests. In Milestone 2, you actually are writing a small main program that's going to launch your map visualization. And that's what your TA is actually going to run and mark. So you're going to make some modifications to main.cpp. And then you're going to start writing a draw map function. And let's see, I actually see a small typo here, so I'll just change this. We changed the name of this slightly, so it looks like that. All right. Okay, and this is where most of your work is going to go, in draw map and a whole bunch of helper functions that know how to draw your map. Okay, so are you also writing an m2.cpp? Yeah, you probably will. So you'll write something. You're going to write most of your code. You're going to write a little bit of code in main.cpp. Okay, so write a little. And then you're going to write this in libstreetmap somewhere. libstreetmap/source somewhere. You can pick anywhere. A common one would be to write it in m2.cpp, but you could write it in drawmap.cpp. You could write it in 10 CPP files. It doesn't matter. We'll compile anything we find in there. But yes, you should write your actual drawing code in libstreetmap source in one or more files whose names you choose. Hopefully that answers your question. Okay, so I just told you that you have to modify your main function. And these modifications are not going to be extremely large. So what does your main function look like? So this is in main/source. Okay, so main/source. There's a main.cpp already, so you're going to make some changes to that. You include m1.h, you include m2.h. Those are header files we wrote for you that give the function prototypes that you need. Basically, m1.h, you've already written all those functions, and they may be helpful to you. So we're going to include the header file for m1.h so that you can use those functions you just finished writing if you like. Programs always start in a routine called main. So this is where your program's going to start for your real program, your program called mapper that your TA is going to run. And you may not have seen this before, but the prototype we've given you for main is the full prototype. There's kind of the real prototype that C++ uses for the main function. And basically, this allows you to pass in command line options. So you're told how many words did the user type at the command prompt, and then what are those words. You can choose to use this to get the map name if you want. So that's one way you could get the name of the map that you're going to work on. It's not the only way. You could also have your user interface have buttons that allow the person to choose what map. But basically, in Milestone 2, we're asking you to be able to visualize any of the maps we've given you. We've given you around 20 maps without recompiling. So somehow you have to get the name of the map that you want to draw from the end user. And as I said, one way would be to actually write some code to examine these arguments that the user typed on the command line. But that's not the only way. Okay, now what else are you going to do in this main function? Well, you're going to call load map, which you wrote in Milestone 1, to load up some map. So I haven't written code here, but this code might extract the name of the map from these command line options. Okay, and you can find lots of examples of how to extract names from command line options on the web, or you can post on Piazza. Or as I say, there are other ways you could just basically always open Toronto at first or not open any map at first and have a button in your user interface to let people open a map. Any of those are fine. But the way I'm going to do it in this example is we'll assume that we've written some code to figure out from these command line options what map you want, and now we load it. Okay? We should always check, well, what if the person typed garbage input? They just type map name is Bob. Okay, that doesn't work. So if that happened, we basically print an error message and then we exit the program. By convention, when you return from MAME, it means you actually end the program. And by convention, if the program didn't exit normally, you return a number that is not 0. So that means an error happened of some type. So we just chose to return 2. If everything went fine with this load, then we go and draw the map. Okay, and that function doesn't take any arguments, and its prototype is defined here in m2.h. So it's going to do our drawing. Once the end user is finished interacting with the map, they basically hit a button, a proceed button, which is like an exit button, go on to the next thing. Then only then do we come back from here. So this function is going to run for a long time. This function basically actually draws the map, interacts with the user, does whatever the user wants, pans, zooms, highlights things, all sorts of stuff. When the user is done, they can click a button called proceed in the UI, or they can click the X in the UI, and they're basically going to be done with all their drawing. And you're going to come here and you're going to clean up your data structures just like you did before. Okay, so the only function that's new here is this one. Okay, the other ones you already wrote in Milestone 1. You're likely to add new data as you're finishing Milestone 2 to your load map and clean it up in your close map. But for now, we haven't done that. So this is the only new function. I see someone asking, what is map path? Okay, so map path is a string, because remember in Milestone 1, we always needed the name, well, the entire path to some map file in order to open it. I haven't shown you the code to set it up, but there would be code in here that would be math path equals, and there'd be some stuff. Okay, so maybe I hard code it to Toronto, maybe, which is not great because we told you not to hard code it. Better way to do it is maybe I get it from these command line arguments. Okay, but I've set it up and now I load it. Does it make sense? Okay. What you should do in your program though is you always want to call load map first, okay, to set up your data structures, then call draw map, and at the end call close map. All right, so that is the structure that you want to use. Your main program should do that. To help you test your drawing routines with a lot of different maps, we also have ECE 297 exercise will also just open and close and draw all sorts of maps. And it always follows this same sequence of load, draw, close. So in your main, you should follow the same sequence. It makes ECE 297 exercise kind of helpful for you as a quick test of, can I draw all sorts of maps? All right, does this all seem clear? All right, so it seems like people got it. Okay, so where do we start? Remember, we're using agile development, and this is something you just want to get used to using for your whole career. Like, it can seem overwhelming. You read the Milestone 2 handout and you go, man, this is a lot of stuff. Like, what do we do here? Where do we start? Well, let's start by just getting the graphics going. Let's get an empty window. Okay? All right, so this is our goal. We just want to open up an empty window. It has, so EasyGL, the graphics interface that we've given you, will do a bunch of things for you. So it's going to set up all these buttons, which allow you to zoom in, zoom out. Proceed basically means I'm done, exit the drawing part of my program. And these arrow buttons let you move around. You can also use the mouse to move around, okay? And the EasyGL Quick Start Guide tells you how all that works. So it's actually not very much code to get this going. Now, this is where we draw our graphics. That's where our map is going to go. This is the main window. We haven't drawn anything because we're just trying to get this window up. Pretty boring, but let's see how do we do that. Okay, and this is one where we've given you, the EasyGL Quick Start Guide gives you an example program. So you want to look at that example program very carefully. The Quick Start Guide explains how it works, but basically an example is a very concise form of documentation. There are a bunch of calls you need to make to get the graphics going. And this is common to basically all graphics libraries. We've made EasyGL as easy to use as we can. To get a window open in a graphics application actually takes a reasonable number of function calls. So if we hadn't written EasyGL for you, EasyGL is written on top of, okay, so EasyGL is written on top of another graphics library, a more full-featured one called GTK. If we didn't write EasyGL on top of it, you would find that you would actually need hundreds of lines of code to get going. Because we've written this nice wrapper layer on top of GTK, you actually don't need very many lines of code. But you want to look at the EasyGL example code that we gave you in the Quick Start guide because it's a very concise form of documentation. How do I get going? Okay. And that's how we created this initial version of Milestone 2. Okay, so I'm inside. Now I'm basically inside of another function. Okay, and I put this one in libstreetmap source. And in this case, we put it in a function called, or a file called drawmap.cpp. Okay, nothing very important about the name of this file, but we do want to put it here in libstreetmap/source. The reason we put it there is it allows us to also use the unit tests that just open and close a whole bunch of maps. If we put this in main, we wouldn't be able to get at it from the unit tests. By putting it here, both our main program and the unit tests can get at it. It makes it easier for us to use exercise to do some extra testing. Okay, so we've got this new file. First thing we do is we include m2.h because that gives us the prototype of this draw map function. And there are two files we have to include to use this EasyGL graphics library. And again, it's in the documentation, but basically, we include this application header file. Some C++ programmers, instead of using .h files, they use .hpp. So that just means .h file. It's the same thing. And this other header file is graphics.hpp. So these two header files are what we need in order to use EasyGL. So what do we do now? Okay, this is the draw map function that is going to be called by our main or by the unit tests after load map. So we need to get a window going. Okay, we've included EasyGL so we can call its functions. And there's just some kind of boilerplate code here that you're just going to take and you're going to use. So what are we doing? So we basically say, okay, create me an object, which is like an EasyGL settings object. Okay, that's all I did there. And I'm saying I need that to have something called a resource. A resource is a file that just describes how are the windows laid out. And we've made one for you already called main.ui. So you're going to say, okay, that's the resource file I want. I want libstreetmap/resources. So you already have used libstreetmap/source for CPP files and header files. There's another folder called resources, which is basically stuff your map needs, which is not C++ code. That includes this file that defines the window layout. And again, we've given that to you. So just write this exact line. We're also going to say that there is a window called main window, and there's a canvas. Okay, so a window is just a region of the screen that is associated with our program. And there's a canvas, which basically means something we can draw on, and it's called main canvas. So we've set all this up for you. Basically, these names, main window and main canvas, exist inside this main.ui, the UI layout that we created for you. So you're just going to use these names. You're not going to change them because if you change them, you have to change other things. Okay, so we've made these settings, and then we basically create an application object. So EasyGL there's something called an EasyGL application object, and we're going to create an object called application, and its constructor is going to take these settings. All right. All right. Let's see. Yeah, you will read the EasyGL Quick Start Guide describes the functions inside of these headers, or describes some of them. And if you open up these header files, I'll probably do that for you in a minute, you'll find that they're heavily commented. Okay, so this is basically your documentation of what can you do with EasyGL. All right. And I see a question, do you have to add anything else in draw map? Not much. So your draw map is actually not going to be super complicated. So right now I'm just putting enough in draw map to open an empty window, and through the tutorial we'll gradually add a little bit more to it to make it a more interesting window. But your draw map just gets the window on the screen. It doesn't actually do the redrawing. So it doesn't do the really complicated stuff. It's just going to get your window to display. All right. And right now we're just trying to get an empty window. All right, so this just talks about what I said. This main UI function we've already created for you, and it defines the window layout. And this has created our EasyGL application, so it's an object. Okay, and then we take this object application, so that's the EasyGL object we just created, and we call its member function run. And its member function run takes 4 arguments. And those arguments are something you might not have seen yet. They're actually function pointers. Who's seen a function pointer? Do you know what that is? Or another word for it would be a callback function. Okay, and I wouldn't expect that you know what these are yet. I'm going to talk about them a little bit in lecture. Basically, these are just, you can pass the names of functions into another function, okay? So EasyGL is passed up to 4 functions that do various things for it. Because EasyGL, when you call application.run, this actually passes control to EasyGL. This function is not going to come back for a long time. It is actually going to respond to mouse clicks, respond to keyboard inputs, redraw the graphics, do all sorts of stuff. So this function does a lot. And it could run for hours if you decide that you just want to interact with your program and not come back for a long time. Now, it can take 4 callback functions to respond to things like I need to redraw the window, I need to respond to a mouse click. But for now, we're not passing any callbacks. We're passing null pointer, which means I'm not going to give you any functions to respond to anything. Okay, so for all 4 things that you can respond to, I'm just not giving you a function. You're not going to do anything. So this is not going to be a very interesting graphics application because the window, we're going to open a window and the window won't respond to anything. Okay, but that's all we're trying to get done right now. Does it make sense? So you're going to see as we go to more complicated examples, we'll actually start replacing some of these null pointers with function names. Okay, so we'll pass function names so that EasyGL, when certain things happen, it can actually call a function that we wrote and make something interesting happen. But for now, we're just passing it null pointer, which means I didn't give you any function to do anything. When the user does stuff, just don't respond. Okay. Any questions on this? Does this make sense? Yeah, and I see a very good question of it, EasyGL configurable or read-only. Yeah, it is completely editable by you. The reason is EasyGL, most students will actually just do the project without modifying EasyGL. You don't have to modify it at all. You can just use it. We make it read-write because, as I said, EasyGL is layered on top of a more powerful, more full-featured, more low-level graphics library called GTK. So you might want to use some of the features of that underlying, more full-featured graphics library. To make that easier, we just give you all the source code for EasyGL and you can change anything you want. You can, in fact, just delete the whole thing if you wanted to not use it. I don't recommend that, right? You could delete the whole thing and go straight to GTK, but that makes the project a lot harder. And you do not have to make any changes to EasyGL. So it does have all the features that it can do everything you need to complete the project. But some students feel like, look, I want to make my UI look different. I want to have extra features. So they want to go in and edit it a lot. Both of those things are fine. Okay. Yeah, I see a question. We would pass different arguments as you progress. So yeah, you're going to see during this tutorial that I'm not going to leave all these with null pointer forever. As we make our UI more interesting, we're going to start passing in functions so that it can actually do what's called a callback. Something happens and it can call back to code that we wrote. Okay. And this is very common in user interface applications where you basically you register functions that will be called when certain things happen. Okay. I see a question. Are we required to edit the UI for extra marks for M2? No, you're not required to edit the UI. We're asking you to do something beyond what the basic requirements of what we asked you to do, but we give you a whole bunch of ideas what that might be, and you might come up with your own ideas. So, for example, you could get extra data from the lower level OSM information and draw subway lines, draw bike paths. You could get information off the web. And if you did those things, then you likely would conclude, well, I don't want to change the UI because it's too much work. I don't want to do everything. Okay. But you might go, I want to change the UI. That's what I feel is cool. You choose. Okay. And my advice to you is don't try to do everything, because you don't need to make a million extra features. If you're having fun and all your courses are going well, you can do it, but you don't want to try to do too much, right? And neglect your other courses or stress yourself up too much. Okay, so this is our newly created window. I already talked about this a bit. EasyGL creates these buttons for us, and these buttons actually already work. Okay, we have buttons to pan, so to move around, and we have buttons to zoom in and out. And this proceed button is special. That means the proceed button actually is what makes us come back from this application.run. So when you hit proceed, this function actually returns. And the way we've written this, that actually means draw map would return. Okay. And if we go back to the start of our program, after draw map returns, we would have closed maps and then we would have ended our program. Okay. So that proceed button actually closes the graphics window and keeps running whatever comes next in your program. All right. So that is our empty window. Let me go and demonstrate that. Let's see. Okay, so I've got this project open in NetBeans, and let's go look at what the code looks like. And let's see, let's go up here. Whoops. All right, so you're seeing a bunch of different code here. This is the minimal one. Okay, so we've got a draw map minimal, and it basically does what I just showed you. Okay, it creates this settings object. It sets a few data members inside that settings object, and you just want to leave these settings alone because they're connecting us to the main.ui, this layout file. Okay, so we created a layout file to you, and we're just connecting to it basically. And then I said we create our application. So you can see here we've created the EasyGL application object. We passed the settings into it so it knows what to do. And then we call this run function. Okay, so that's our draw map. And it's pretty simple. Okay, and let's see, I'll show you the main program. And well, actually, I don't have the main program open here, but basically my draw map function just calls that one helper function. Okay, it calls draw map minimal. So let's run this. Oops, it says build failed. It shouldn't have failed. Okay, so if I run this, let's see what happens. Okay, so it called my load map. You don't see that, but if I look at the, well, let me show you that too. So if I look, this is in libstreetmap. Okay, so I put this in a file called drawmap2, which is in libstreetmap. And then if I go look in main, there is a little bit of a main program, whoops, in main.cpp. And you don't want to look at all of this too much. It basically has the option to get the name from the command line, but it calls load map on the map path. It calls my draw map function, and then it closes the map. Okay, so my main function is pretty simple, right? There's a little bit of code to figure out what map to open, which I'm not really showing you because you might want to do it that way or not do it that way. And then there's load the map, draw the map, close the map, end the program. So that's all I've got. Okay, let's go back to draw map and let's make sure this is running again. And let's see, where is my application? Yeah, so there's my application. And it's alive, but it's kind of boring. I can zoom in and well, actually zoom in didn't even work. So I didn't basically do anything very interesting in this. I haven't actually given it enough callback functions to do much of anything. Okay, so I can just look at this, and when I hit proceed, it's going to close, and I go back to my draw map function, finish it, finish my main program. It's all over. Okay, so let's go back and see. Whoops. Let me shrink this down. Okay, so that was my empty window. Not super exciting. Okay, so I want to do more than that. I want to basically draw on this part. Okay, that's my main, what's called my main canvas in the UI layout that we created for you. And that's where you're actually going to draw your map. So I want to do more. Okay, so most of this code is the same as what I just showed you. Okay, so you look at all of this code, it's the same, right? That's just getting my window open and passing control to EasyGL. But now I'm going to do a little more. First, I need to define a coordinate system. If I'm going to draw, I need to choose what coordinate system I'm drawing in. And that's what this is doing. So I'm making an object called of type EasyGL rectangle, and I'm giving it a name of initial world. Okay, so I'm making an object called initial world, and it's a rectangle. So it takes 2 points. And basically the 2 points I've chosen are 0, 0, and 1000, 1000. Okay, so that is defining a rectangle with coordinate 0, 0, and 1000, 1000. So the first coordinate is like the minimum x, the minimum y. The second coordinate is the maximum x, the maximum y. So that's what I just created with this initial world. On my EasyGL object application, so that's my main EasyGL object, there's a function called add canvas. And add canvas, basically in the UI we've given you, the layout, there's a canvas, a drawing region called main canvas. So you want to use that name because it matches the UI layout we gave you. And now you pass in 2 arguments. So we're going to pass in the name of some function, can be anything you want, but it's a function that knows how to redraw, like how to draw graphics. So this is what's actually going to do all the drawing of our streets or intersections or whatever. And we're going to pass in the coordinate system that we want. Okay, so this initial world, this is the coordinate system that we just defined up here. So we're saying we want to draw in a coordinate system that goes from 0, 0 to 1000, 1000. And whenever this main canvas needs to be redrawn, the map visualization needs to be redrawn, we want EasyGL to call this function. Okay, so it's got to call draw main canvas. We're going to go need to write that function, but this is just connecting it. So we've connected it to EasyGL so it knows that's the redraw routine you want when the window needs redrawing. Does that make sense? If not, it may make more sense in another minute. Okay, so this is like plumbing. I just connected everything together and I chose a coordinate system. Now I need to write that drawing callback. So again, this is called a callback because I'm not going to call this function. EasyGL is going to call it. Because I told EasyGL, this is the function to call whenever you need to redraw that kind of main drawing part of my window. Okay, and this callback has to have a certain signature. So it can have any name you want. And we already have chosen the name draw main canvas because that's what we told EasyGL to call. It returns nothing, so it's void. And it takes as an input an EasyGL renderer object. Okay. And this supports drawing many different things. So this is an object that you don't really need to know what's inside of it, but it's basically what allows us to call drawing functions inside EasyGL. All the drawing functions are member functions of this renderer class. Okay, so it's passed into our redraw function, draw main canvas. And then we're going to, right now, what we're going to do is we're going to say, okay, take that function, G, and call it draw rectangle member. And it has a draw rectangle member. So all draw rectangle does is it draws a rectangle between 2 points, x low, y low to x high, y high. Okay, so x out, so it takes 2 points. Whoops, that should be x high. Sorry about that. Okay, so it takes 2 points, and it's just going to draw a rectangle. It draws the outline of a rectangle between those 2 points. So we're going to pass in the same 2 points we did before to initial world. We say we want a rectangle between point 0, 0 and 1,000, 1,000. Okay, and that's all we do. So our redrawing function only knows how to do one thing. Just draws a rectangle every time it's called that is that size. How big do you think this will be? How much of the screen is this going to take up? Is this rectangle going to be little? It's going to be big? What do you think? So to answer that, you need to think about what coordinate system we asked for. Okay, so this is the coordinate system we asked for. We asked for a coordinate system that goes from 0, 0 to 1,000, 1,000. Yeah, so this is going to be pretty big, right? We basically are saying draw a rectangle that is the size of our whole coordinate system. So we expect this to be pretty big. So this is what it's going to look like. I'm going to show you a demo of this in a moment, but it looks almost the same as before, except we actually have a rectangle here. So you can see there's a rectangle outlined here. It goes right to the top of the window, right to the bottom of the window. It doesn't actually go quite to the left or the right. The reason is the window's not, in this case, the window's not quite square. EasyGL always makes sure that it essentially preserves a unit in the X direction is the same number of pixels as a unit in the Y direction. So because the window is not quite square, it's going to give you a little bit of extra real estate on both sides of the window. So the rectangle fills the window vertically in this case, but doesn't fill it horizontally. But that's fine. It's actually doing some work for you to make it easier for you. No matter what shape the window is, your graphics are not getting distorted. It's keeping 1 unit of X is the same number of pixels as 1 unit of Y. Okay, hopefully that makes sense. And I'm going to go show you what that looks like. And we didn't have to write much code to do this. Okay, so let's go look at this. So the first function that we used was this draw map minimal. I'm just going to comment that out. And I'm going to uncomment draw map blank canvas. Let's go look for that. Okay, so basically my draw map is calling a different helper function. So my draw map blank canvas is almost the same as what we had before, all the boilerplate code to open up a window with this new stuff. The new stuff is setting a coordinate system from 0, 0 to 1,000, 1,000, and it is connecting a redrawing callback. So it says when you need to redraw, call this function. Okay, now we need to go look at that function. We have to write that, and here it is. So draw main canvas blank. Remember that the EasyGL example application and the quick start guide show you what the function prototype for this must be, what the function signature must be. It must take an EasyGL renderer pointer, and it must return void. Okay? And let's see what this looks like. Okay, so if I basically rebuild this, I'm going to get this new draw map function. And now let's run it. Okay, so it's not super exciting. Let me blow this up. It does indeed show this rectangle that we drew. And let me make this a little smaller again. Okay, so, and I can zoom in. So if I zoom in, I can pan over. I'm actually now just, as I zoom in, I'm seeing less than the whole rectangle. Okay, so these buttons now do something useful, because every time I click one of these buttons or I resize this window, my draw map is actually getting called. Or it's not my draw map, sorry, my redraw function, my draw main canvas function is getting called. Because EasyGL has no idea what I want to draw in this region. What it does know is if zoom in is clicked, it should adjust the coordinate system, and it should call my redraw function. So it did that, and even though I draw the same rectangle every time, it shows up on the screen differently as I zoom in and out. And I didn't actually have to write any code to do that. Okay. Is there a maximum bound the rectangle cannot exceed? No, so I could make this rectangle as big as I wanted. I could make this rectangle much bigger than 1,000 by 1,000, and it would just fill the whole screen and then some. But that would be fine. So there's no bound. It's not. Oh, okay. Sorry, are you guys? I guess I have to reboot my router. Can you guys hear me again?
Yeah, now I can hear you one. I think you cut off.
Okay, sorry. Apologies for that. Um,
Oh,
okay, so we can now interact with our window, but it's not super exciting. Okay, so if I click this proceed button, remember that's the one that returns from that application.run call. So this is going to go back to my draw map, which just returns to main and ends my program. So I click proceed and the graphics shut down and my program ends. Okay, so is a bit more exciting, but maybe still not the most exciting application that you've seen. So let's go back here. Okay, so, but we've actually made a lot of progress. Like we've already got a window up, and it can redraw itself. So that's actually a lot of progress, and we've done it by kind of following the template of the EasyGL example program. Okay, now I want to start actually drawing something more interesting. Okay, so I want to draw just intersections. So in Milestone 2, we ask you to draw all sorts of stuff, streets and features like parks and buildings and so on. I want to start just by drawing intersections. And you might not actually draw intersections in your Milestone 2 because we don't ask you to draw the intersections, but they're kind of easy to get going with and they'll show you how to draw things. So the way I'm going to do this is first I'm going to store some information about the intersections and then I'm going to draw them. So to make your drawing faster, you might store extra data in load map. Here I'm just going to store some extra information in draw map before I call this application.run. That works, but probably it'd be better style to actually load up this data in load map. For simplicity, I just haven't done it there. I've done it in draw map. Okay, so I've created a new global variable called intersections. It's a vector of intersection data. So for every intersection, I'm going to have some data. What data do I have? Well, I just made this structure up here. Okay, so remember a structure is just like a class, but all of the data and member functions are public by default. So this just has two pieces of data and they're public. It's got a lat long position and it's got a string name. So every intersection, I'm going to store its position in latitude and longitude, and I'm going to store its name inside this this vector. Okay, so in draw map, I basically create this vector by calling, well, resize is going to make an empty entry in this vector for every one of the intersections. So I say, tell me how many intersections there are. And for every one of those intersections in the city, make my intersections vector that big, which means every entry in it will be created. Okay, it will have just default data, but it'll have been created. So maybe just type this in the chat. If I want to initialize, this might actually be hard. Might be hard for me to ask you to do because you may not know what we're doing here. I basically just want to store the position and the name of every intersection inside this vector of intersection data. So if anybody's got the confidence to do this, just tell me roughly what should I do. Do I need some if statements? Do I need some loops? Do you remember what functions I should call? How should I do this? Yeah, I could use intersections.pushback, except I already just created an empty entry. So I basically, this resize just created entries for every intersection in the whole vector. So because of that, I'm not going to use pushback. I've created all the entries I can now just assign to them with the square bracket operator, right? So, but you're on the right idea. So what do you think? Do I need some if statements? Do I need a loop? Do you remember any of the functions I would call in Streets database?
could
Yeah, so I
you?
see Nicholas saying intersection dash position, intersection dash name in a loop, and that's all there is to it. It's not very complicated, and you probably don't remember exactly what to call. That's why you probably have to go look at Streets database or your M1 solution to see, well, what do I call to do this again? But to load this up, we're just going to go through all the intersections in the city. Okay, so from 0 to number intersections, and we're going to say, okay, let's store the position of that intersection uh, in the vector, and let's store the name of that intersection in the vector. And Streets database actually gave us functions for both these things, right? We had a function called get intersection position, and we had a function called get intersection name. And I've decided I just want to store all this stuff in advance so I don't have to call Streets database. I don't have to do it that way. When I'm redrawing, I could just call Streets database, but I've decided I want to preload it because I feel it'll be a little faster. And yeah, intersections do have names. They're really intended just for kind of output. They're not guaranteed. They're not guaranteed to be unique. So the intersection names are really intended just for printing things out to the end user, but they do have names. Okay, so I've loaded up some data by calling Streets database. Every single intersection now, I have its latitude and longitude stored, and I have its name stored. Okay, and then I'm calling my application.run again. Okay, I need to draw something. I'm trying to draw all my intersections. So how am I going to do that? Sorry, let me get my get my video off my slide so I can see myself. Oops. Okay. Okay, so I'm going to do my drawing in my callback function. So remember we told EasyGL that we have a function and we named it draw main canvas that it should call whenever it needs to redraw the window. And what that function used to do was it just drew a rectangle from 0, 0 to 1,000, 1,000. Okay? So I want to make it more interesting. I have this data available to me now. I just loaded it up. So it's just a reminder that data exists. Anybody want to type into the chat, how would I draw all these intersections? I want to draw them all the intersections in the city. So what should I do? And there's a function in EasyGL called fill rectangle. So fill rectangle is just like draw rectangle. It takes an X low, Y low point and an X high, Y high point. So it takes 2 points. And instead of drawing the outline of them, it basically just fills it in. Okay. Yeah. So, okay. So that's a good point. So Samuel's saying first convert latitude and longitude to Cartesian. That's actually the right way to do it. Okay. So you're exactly right. Convert latitude and longitude to Cartesian, like an XY location on the surface of the Earth, and then draw that. We're going to get there, but first I'm going to do it the wrong way. Okay. So I'm going to do it a simpler way that's not very good, but you've already given me the better way to do it. Okay, and then Nikita says, and then you have to normalize so it all fits within the rectangle limit. So that's also correct. So I've said my coordinates are from 0, 0 to 1,000, 1,000. So I actually should make everything that I draw fit within that. So that's also correct. So Nikita, you're completely right. I need to make sure my drawing and my coordinate system match. But I'm going to do this wrong first, just to demonstrate a simpler approach that doesn't work. So I'm going to go through and I'm going to basically, for all of the size t is just an unsigned integer. So you can interpret that as just int, it's fine. So for every intersection from 0 to intersections.size, so that's all the intersections in the city, because I already loaded this up with all the intersections in the city, get the x coordinate, get the y coordinate, and these x, y's are actually just the latitude and longitude. Okay, I just took the latitude and the longitude. And then I set a hard-coded value. I said my width of my rectangle is 10, my height is 10, and then I said, okay, I've got this renderer object that was passed in, and we assigned it to a variable named g. So we're going to say g, and we have a little bit of an error here. We're kind of using pointers and references sort of inconsistently, so I'll fix that in the slides after. But basically, g fill rectangle. So call the member function fill rectangle that the renderer gives us and pass it in 2 points. The first point is xy, so the latitude and longitude of this intersection. And then the second point is width and height offset from that. Okay, so we're passing in really a latitude and longitude because that's what my x and y are here. And we're basically taking lat plus 10 and well, it's actually longitude. Sorry, I've reversed my x and y. This is really longitude and latitude. And up here, the other coordinate I'm doing is longitude plus 10 and latitude plus 10. Okay. So that's what I'm drawing. And I'm saying fill that in. I haven't actually said what color. It's just whatever color was selected. So that's really not great style either. I should probably set the color. But you get the idea. Um, okay, so Samuel has noted that this really isn't great. We're drawing latitude and longitude. So that's actually going to be a problem. You're correct. We should have converted this to proper Cartesian coordinates like we did in milestone 1. And Nikita's also flagged another problem of we don't appear to be paying any attention to the fact that we said we're drawing between 0, 0, and 1,000, 1,000. We just now have decided that we're going to draw in latitude and longitude. Okay, so what do you think? Is this going to draw well or not? And I guess the answer is it doesn't. This is actually what it draws. Okay, it looks pretty blank. All right, so remember we drew this rectangle from 0, 0 to 1,000, 1,000. So I can see that. See this big rectangle. Where are all my intersections? I don't see any intersections. Any ideas? Where'd they go? Bottom left, out of bounds. Yeah, so both good answers. They're actually here. They're all on top of each other because latitude and longitude for Toronto don't vary by very much. Toronto's latitude is, 49 degrees and its longitude is about negative 79, and it only goes up or down by a little bit because latitude and longitudes are, 1 degree of latitude or 1 degree of longitude is a lot. So we've just drawn uh, we've just drawn everything to be 10 units wide and high, and they're all around here. So they're all on top of each other. We drew about 160,000 intersections, mostly on top of each other, and it's that little dot. Okay? So didn't draw very well at all. And let me quickly demo that so you can just see that. Okay, so let me go down. All right, so go down here. That was my blank canvas one. And this is draw intersections. It's really lat long, okay? It's not a great function name, but it's really at lat long. And we drew it directly. Okay, so now I'm compiling, I'm running, and yeah, it's all in the lower left corner, so not great. And if I want, I could zoom way in, but there's so many intersections on top of each other there that this is just going to look like a blob no matter what. So that is the city of Toronto. It's not super exciting, okay? So I hit proceed. Once again, that'll get me out of my redraw function or application. Okay, so let's see if I can get through one that gets a little more interesting, and then we'll end the tutorial for today and pick it up again next week. Yeah, let's see, get back here. Whoops, sorry about that. Okay, so that didn't work too well. So what do we have to fix? I guess you guys have already flagged it. There were two problems. We really shouldn't have been drawing latitude and longitude. But let's say I'm not going to fix that yet. My bigger problem is my coordinate system and my drawing don't make sense together. Okay? So in this renderer, I'm now going to change. Yeah, well, basically, I already told you this. So before I get into how we change it, the problem is the latitude and longitudes are all around for Toronto negative 79 degrees plus 49 degrees. And they're very close to that. They may go up or down by maybe half a degree of longitude. So that doesn't make any sense with this coordinate system we used of 0, 0 to 1,000, 1,000. Okay? So how would I think I'm going to skip the breakout rooms just in the interest of time today. How would I find the map bounds? So basically my coordinate system, I don't want to change this coordinate system to be something like negative 80, 49 to negative 78, comma 50. That would be a better coordinate system if I draw in latitude and longitude for Toronto. But it's not going to work for any other city, right? It's going to be a bit, so this is not going to be good. That would be better than just choosing 1,000 to 1,000 as my coordinate system, but it's not good. Um, so what I'm going to do instead is I actually want to figure out if I've chosen to draw latitudes and longitudes, I want to figure out what's the biggest latitude, what's the smallest latitude, what's the biggest longitude, what's the smallest longitude. If I can figure all those things out, then I could use them to set a more reasonable coordinate system. And it's going to work for more than one map because I didn't just hard code it. All right. Let's see. Lat long of intersection 0. Okay, so see Arthur's saying set the lat long of intersection 0 up here. So you can just basically set these to the first intersection. That makes sense. And then basically you're saying go through all of the intersections, and for each of these, just take the max and min of each intersection and what you already had. And yeah, and that's exactly right. And Sam was saying, isn't that similar to fine street bounding box? And it is very similar. So that function actually kind of taught you how to do this already. So what does the code look like? Yeah, you just told me. So we can set our maximum latitude and minimum latitude equal to the latitude of the first point. And then we can go through for every intersection. And technically, I could start at 1 here if I wanted. So I don't have to do 0, but it's fine. Just waste a tiny amount of work. And I basically say, well, the maximum latitude is the maximum of what I had before and the latitude of the intersection I'm looking at right now. So it's a lot like what you did for fine street bounding box. And basically equivalent code for the minimum and equivalent code for the longitude. So after I come out of this, I actually have all these things properly set to the maximum, minimum latitude and longitude of the whole map. And it's going to work for any city. So it's way better than me hard coding it. Okay, once I have that information, so I've written that code, probably my load map, that would be a logical place to write that code. I can use it, just store the values, the minimum longitude, the maximum longitude, and so on. And I can use that to set my coordinate system. So remember, we set our coordinate system by making an EasyGL rectangle. We called that object initial world, and we passed it into this add canvas function, the function that sets up our main drawing area. And I'm actually now also saying I want to use a different redraw function. So I pass in the name of a new redraw function that is draw main canvas, but I've fixed the coordinate system, what's called the world coordinates. And then I call, application dot run. Okay, so which basically tells EasyGL to go and take control and start drawing the screen and responding to the user. Okay, so all this makes sense. So I've computed a much more logical coordinate system. It's going to work for multiple maps, and I'm passing it into EasyGL. What happens? So this is actually what happens. So if you run this code, you just get a big black box. So something went wrong. Any idea what went wrong? It might be subtle, but I can go show you what. This is where you would actually now put breakpoints in and start printing out what's happening to see, well, why did this go so wrong? But I still made a mistake here. So any ideas of why this looks like this? We're really zoomed in. Good guess, but it's what'll actually happen is, whoops, I don't want that. All right, sorry about that. Now, when we run this application, it will start with this initial world basically filling the screen. Okay, so we're not really zoomed in to start. We could really zoom in later. Drawing out of bounds, we're not drawing, well, kind of. It's not that we're drawing out of bounds is okay in EasyGL. If you draw off the screen, it just ignores it. Okay, so it doesn't cause any bad problems. Let me give you a hint. I didn't change this so far. This width and height. I'm still drawing rectangles that are 10 units wide and 10 units high. And now that I've actually got a coordinate system that's more reasonable for latitude and longitude, it goes from, say, negative 80 to negative 78 in longitude. 10 is really big. Okay, so I'm drawing way too big basically the rectangles I'm drawing are just way too big. I have to think about these sizes also making sense in my coordinate system. Okay, so we need to make our rectangles smaller. So they were way too big. If you play around with it and you set them much smaller, 0.001, so a thousandth of a degree of latitude or longitude, it looks much better. And let's see. And let me basically, I'm not going to answer this question right now. I mean, well, I'll ask that maybe in a minute. But basically, this is what it'll look like now. So this code will actually start drawing something reasonable. So this now looks like Toronto. We have a point map of all the intersections in Toronto. And let me quickly pop this up. Okay, so that one pre-coded this, and that is XY fixed world. Okay, so that is our better version of draw map, chooses a smarter coordinate system, uses a redraw function that also uses that coordinate system. So the coordinate system and the redraw now makes sense. And if we run that, yeah, we get this. Okay, so we get something that looks much more reasonable. And now zooming in and out actually looks much more reasonable. As I zoom in, you can see the rectangles look bigger because we're always drawing them the same size. We're drawing them 0.001 in latitude or degrees of latitude or longitude. So that gets bigger as I zoom in. And I can pan over and move around. I didn't actually write any of the code to do the zooming in or the panning. EasyGL is doing that for me. It's just calling my redraw function, and I'm always drawing the same Toronto. I'm drawing it in the same coordinate system. EasyGL is just changing how it maps that coordinate system to the screen because it knows if it's zoomed in, then it should only be mapping a part of it. But it's doing that for me. I didn't have to do anything to make that work. And I see someone saying, isn't that 0.001 hard coding? Yeah, it is hard coding. So I really should make that some kind of defined constant. And you're going to see next week, we'll kind of leave it here for now. And we'll go through further enhancements of how to make this work better next week. But we're already in a much better state. And yeah, I would not leave that 0.001 as just a number in my code. I'd go and define a constant with a big comment around it. But you're going to see we're going to actually change this some more next week so that we can also kind of get rid of that completely arbitrary 0.001 because it's a little hard to reason about. Like that's basically 1/1000th of a degree is how of latitude or longitude is how big we want to draw our rectangles. If we did that, we should define a constant and put a big comment in. But there was a comment earlier of we really shouldn't do this in latitude and longitude. We should convert it to X and Y to Cartesian coordinates, and that is better. So we're going to do that next week because there are still problems with this. Okay. And can I turn off the sound notification? Sure, I'll do that. Okay, that ends the first hour. You got a bonus 10 minutes. And hopefully, yeah, we'll pick this up next week and finish the walkthrough. And we'll be talking about kind of more background on what are callback functions and etc. and how EasyGL works in the lectures.